Separating techniques. Matter exists in form of mixtures. A mixture is made by mixing of two or more pure substances. There are two types of mixtures, homogeneous and heterogeneous. We can separate the two mixtures by different physical processes. 1. Evaporation. 2. Filtration. 3. Centrifugation. 4. Sublimation. 5. Chromatography. 6. Distillation. 7. Fractional distillation. Heterogeneous mixtures can be separated by physical methods like handpicking, sieving, filtration, and crystallization. Separation of two miscible liquids requires either distillation or fractional distillation method. To separate two immiscible liquids, a separating funnel is used. Let us learn about separation of salts from seawater. Seawater contains salts like sodium chloride, potassium chloride, and magnesium chloride. These salts can be separated from seawater by evaporation. Water evaporates from seawater, leaving salts behind. Evaporation can also be used to separate colored components from blue-black ink. It is a homogeneous mixture. Dyes can be separated from the solvent by evaporation as shown in the animation. Filtration is a process which is used to separate insoluble solute from the solvent by using a filter paper having pores of correct size. This method is used to separate mixture of a solid and a liquid. Let us have a look at how a filter paper is folded for filtration. A circular filter paper is first folded along its diameter. It is then folded along the middle radius. This filtered paper is then reconfigured as shown on the screen. The filter paper is then placed on the funnel and is wetted with distilled water so that the paper funnel sticks with the wall of the glass funnel to avoid any air space. A solution of sand in water is then poured on the filter paper with the help of a glass rod. Residue is left on the filter paper and filtrate is collected in a beaker. Centrifugation is a process that separates substances of different densities in a sample by rotating the sample at very high speed, causing the substance to be displaced outward. Let us perform an activity to prove this. We take a bucket of muddy water tied with a rope to a central support. When this bucket is rotated at a very high speed for some time, we find that the sand separates from water. This is because centrifugal force and gravity act on the rotating bucket. Difference in densities is responsible for separation of components of a mixture. Can you recall any application of this method? Yes, you are correct. We separate fat from curd by this method with the help of a churner. The rotating cylinder of washing machines acts like a centrifuge, which helps in removing water or soap solution from wet clothes. In the laboratory, we separate precipitate from solutions. Separation of components of a mixture is done by using a centrifuging machine. Let us perform an activity to understand centrifugation. For this, we take 4 different test tubes containing blood, muddy water, calcium sulfide, and ink. When these are centrifuged at 500 rpm, we find that both centrifugal force and gravity act on them. When the machine is stopped, we observe that solid portion has separated from the solvent. In the first tube, dyes have separated from the solvent. In the second, blood cells have separated from the plasma. In the third test tube, mud has separated from water. And in the fourth, calcium sulfide precipitate has separated from the solution. Let us now learn how to separate a mixture of oil and water with the help of a simple apparatus called separating funnel. Oil and water do not mix well with each other. If this mixture is put in a separating funnel, and kept undisturbed for some time, what do we find? We find that oil, which is lighter than water, forms the upper layer, and water being heavier forms the lower layer. By opening the stopcock of the separating funnel, the lower water layer can be drained off. Oil layer remains in the separating funnel. Do you know the principle behind this? The separating funnel uses the differences in the densities of 2 immiscible liquids to achieve the separation. Let's now discuss the application part of it. The separation of the lighter layer of molten slag from the heavier molten iron layer in the blast furnace is based on this principle. Let us now learn about the process of sublimation. A mixture of common salt and ammonium chloride can be separated by using the sublimation technique. Common salt on heating does not form vapor, while solid ammonium chloride on heating gets converted into its vapor state. Ammonium chloride vapor, on coming in contact with cooler walls of the funnel, solidifies and deposits there. Ammonium chloride can be later scraped off. Salt remains in the china dish. How do we define sublimation? Sublimation is a process in which some solid substance gets converted directly into its gaseous state. Iodine, dry ice, that is solid carbon dioxide, are the examples of matter that can sublime. Solid carbon dioxide is known as dry ice because it does not melt but sublimes at atmospheric pressure and a temperature of 78 degrees centigrade to form gaseous carbon dioxide. Dry ice is preferred over ice in the food industry as a refrigerant because it does not have a messy liquid when it sublimes. Dry ice is also used in films or stage performances to produce special effects involving cloud or mist. Let us now learn about the process of chromatography, by which we can detect the components of a mixture and can separate them. We will perform an activity to separate the colored components present in the black ink by paper chromatography. Materials required for the experiment are alcohol, gas jar, jar cover, gas jar saturated with alcohol, sellotape, thread, filter paper, that is Whatman filter paper number 1, scale, pencil, black ink. A fine capillary tube is also needed. There is a stationary phase and a mobile phase. Let us now discuss the procedure of the experiment. Take a thin long strip of Whatman filter paper and draw a line on it using a pencil, approximately 2 centimeters above the bottom of the filter paper. The liquid is the mobile phase and paper is the stationary phase. Mark X at the center of the line. Next, put a small drop of water-soluble ink, that is, from a sketch pen or fountain pen at the center of the line. Let it dry. Lower the filter paper into a jar containing water. So that the drop of an ink on the paper is just above the water level, as shown, and leave it undisturbed. Watch carefully as the water rises up on the filter paper. As the water rises up, it will take the different dyes of the black ink along with it. After some time, we will see that different colored spots at different heights on the filter paper. It shows that black ink consists of mixture of colored dyes. The different colored dyes of the mixture rise to different levels on the filter paper. The dye component of black ink, which is more soluble in water, has travelled a longer distance on filter paper in comparison to the dye component, which is less soluble. This activity is called paper chromatography, as it involves the use of filter paper for the separation of components of a mixture. Let us now discuss precautions to be taken during the experiment. Use fine capillary for sample spotting. Allow the spot to dry before putting in jar. Strip should not be curled when placed in jar. Strip should not touch walls of the jar. Other types of chromatography are also present, such as thin layer chromatography, column chromatography, and gas-liquid chromatography. Can you guess about applications of chromatography? Separation of different substances present in plant extracts. Separation of amino acids in a mixture. Separation of carbohydrates in a mixture. Separation of drugs from natural herbs and flowers. Let us now learn about separation of two miscible liquids by distillation. Sometimes we need to separate a mixture of two miscible liquids such as alcohol and water. The technique used for this process is called distillation. The process is used to separate the mixture of two miscible liquids. Conditions required for the separation are: the liquid component of the mixture should boil without decomposition. The liquids must have at least 25 degrees centigrade difference in their boiling points. The liquids of the mixture should not form azeotropes, that is, constant boiling fractions. Let us take an example. 95% ethanol and 5% water forms an azeotrope, which boil at one fixed temperatures. It is not possible to separate ethanol from water by simple distillation. Let us now perform an activity to show separation of acetone from water. Acetone and water form a homogeneous mixture as they are miscible in each other in all proportions. We take 25 milliliters of acetone and water mixture in 1:1 ratio in a 100 ml round bottom flask. Fit the cork, thermometer and water condenser as shown in animation. Heat the acetone water mixture slowly. Acetone has lower boiling point than water. Acetone will form vapor as the temperature of the mixture reaches the boiling point of acetone. Acetone vapor will travel upwards and pass through the outlet near the neck of the round bottom flask. On reaching the inner tube of water condenser, acetone vapor gets cooled and condenses to form liquid acetone and collects in the beaker. Continue heating till all the acetone in the mixture vaporizes, condenses and collects in the beaker. During this time, we find that the thermometer shows no increase in temperature. The temperature shown by the thermometer will be boiling point of acetone. When no more acetone remains in the round bottom flask, the temperature starts to rise again till it reaches 100 degrees centigrade, which is the boiling point of water. At this point, water starts boiling and forms steam. The steam then condenses in water condenser and is collected in another beaker. Acetone has a lower boiling point than water and hence vaporizes first. If the difference in the boiling points of the liquids in a mixture is less than 25 degrees centigrade, simple distillation may not be able to separate them efficiently. Fractional distillation is used for liquids which have very close boiling points. It is used for separating different components of crude petroleum. Fractional distillation apparatus has a long column tube filled with glass beads. This long tube is fitted at the top of the flask as shown in the animation. The purpose of the long column fitted with glass beads is to help in separating liquids having close boiling points. Repeated vaporization and condensation at the surface of the glass beads ultimately helps in separating liquid mixtures into pure liquids. So what are the applications of fractional distillation? Separating different oils extracted from the plants. Separating different components, kerosene, petrol, diesel, from petroleum. Separating different gases present in the air. Air is a homogeneous mixture of several gases: oxygen, nitrogen, argon, and water vapor. These gases can be separated from each other by using the fractional distillation technique. Cooling of air below 196 degrees centigrade requires several steps. 1. Air is first compressed at a high pressure. 2. The compressed air is cooled to a lower temperature by passing it through a container that is cooled by freezing cold water circulated in the tubes fitted in it. 3. The cold compressed air is then allowed to expand, which results in further cooling to temperature below 196 degrees centigrade. For separation of gases of the air, liquid air is warmed in a fractional distillation apparatus. Different gases of the air will come out from different heights of the fractional distillation column. On warming liquid air, nitrogen gas, which has boiling point of 196 degrees centigrade, comes out first and can be collected from the top outlet of the fractionating column. Argon, the boiling point of which is 186 degrees centigrade, can be collected at the outlet near the middle of the fractionating column, while oxygen remains liquid if the temperature is kept below 183 degrees centigrade. Crystallization is the method which is used to purify impure substances. An impure sample of copper sulfate can be purified by the method of crystallization. For this, we take approximately 5 grams impure sample of copper sulfate in a china dish and dissolve it in minimum amount of water. The impurities are then filtered. The water is evaporated from the copper sulfate solution so as to get a saturated solution. The solution is then covered with a filter paper and left undisturbed at room temperature to cool slowly. What do you observe in the china dish? Crystals of copper sulfate will be obtained. Do the crystals look alike? Yes, all the crystals look alike. The crystals can be separated from the solution by filtration. The crystals are then dried on a filter paper. Applications of crystallization. Purification of salt that we get from seawater. Separation of crystals by alum, Fitkari, from impure samples. Let us now understand the working of a water treatment plant. Impure water is purified for household purposes. Rainwater is stored in a reservoir. It is sent through a pump to a sedimentation tank where it is treated with alum to coagulate the impurities present. Alum makes small particles stick together, forming larger lumps that sink faster. Lime reduces the acidity of water. Coagulated impurities are made to settle down by allowing the solution to stand still for about 15 days. Water is then passed over filtration beds that consist of layers of sand and gravel. Impurities settle over the sand to form a slimy layer of microorganism at the top. Impurities are also trapped in the layer containing gravel. The filtered water is then treated with chlorine in a chlorination chamber. Chlorine reacts with water to form hydrochloric acid and nascent oxygen, both of which kill the bacteria. Water is then supplied to water towers to a pump house. From there, it is sent to houses for domestic use.